Modern software development moves fast, but relying on manual execution for automation scripts inserts a human hand crank into a high-speed machine. In a traditional setup, a developer finishes a feature and deploys the code. Then, a QA engineer manually pulls those changes down, opens their IDE, and clicks Run on their local workstation. That works for a single script, on a quiet afternoon. But in an enterprise environment, where dozens of developers commit code, human execution fails to scale. The backlog piles up. The solution to this bottleneck is removing the human from the execution entirely. We do this through CI/CD. Continuous integration, or CI, is the practice of automatically building and testing the application the exact moment a code change is pushed to the repository. The result of that process is continuous delivery. By running these automated tests continuously, we ensure the application is always in a verified, deployable state. Operationally, the enterprise pipeline functions as a synchronized chain of specialized orchestration tools, all flawlessly communicating across disparate, distributed servers. Moving a solitary Selenium test from a laptop into a robust, hands-free quality gate requires us to completely decouple the test execution from human intervention and localized hardware. Look at this architecture flowchart. A developer pushes an updated code packet directly to the central GitHub repository. Historically, build servers constantly pinged the repository, wasting network resources. Now, we use a webhook. The moment new code arrives, GitHub instantly fires a single webhook payload. That payload is caught by the orchestration layer, typically Jenkins or GitHub Actions, acting as the central nervous system. Upon receiving the webhook, Jenkins immediately reacts by securely pulling a replica of the repository code down into its dedicated, isolated workspace. Jenkins now has the code, but it does not inherently know how to test it. The rules of engagement must be explicitly codified. This graphic displays a declarative Jenkins file on the left and a YAML file for GitHub Actions on the right. These pipeline configuration scripts act as architectural blueprints, dictating the exact sequence of operations the orchestrator must follow. Inside these scripts, we set parameters to dictate the scope of our tests. For a rapid code commit, we configure the pipeline to trigger only a lightweight smoke suite to give the developer immediate feedback on critical functions. We don't always rely on code commits to start the process. Using time-based triggers like a cron scheduler, Jenkins can automatically execute a massive, thorough regression suite every midnight without a webhook prompt. The primary value of the orchestrator isn't actually running the tests itself. Its job is directing the flow of dependencies and instructions automatically. We hit our next architectural hurdle. The Jenkins server now holds the raw code, but it lacks an integrated development environment to actually run it. We attach Maven as our build tool. It acts as the bridge between raw text and tests. First, Maven downloads necessary external dependencies, like Selenium and Cucumber. Next, it compiles the raw Java code into a consolidated executable artifact format. Before execution begins, Maven also validates the underlying structure of the Selenium and Cucumber framework, ensuring there are no fatal compilation errors. Automated tests cannot run in a vacuum. They require a designated target environment to validate against, whether that's a QA server, a user acceptance testing environment, or production. This diagram shows how we manage environmental context using configuration property files. By separating our URLs and credentials into specific files, like QA, UAT, and prod, we avoid hard-coding environment details into the test logic. Jenkins passes environment variables directly into the Maven execution command. This instructs the pipeline to select the correct property file precisely at runtime. During this build phase, we integrate static code analysis to maintain the internal integrity of the framework. We use SonarQube as a quality gatekeeper. It scans the automation code for vulnerabilities or bad practices, catching poor scripting before it ever executes. Maven acts as the factory floor. It transforms isolated code and external dependencies into an executable, environment-aware validation suite. Now we face the final scaling bottleneck. Notice how these test case blocks funnel into a single node. Running a massive regression suite sequentially on a single build server takes hours, severely delaying the delivery pipeline. Differences in browser versions between the build server and local machines cause flaky, inconsistent test failures. We solve this instability with Docker. Containerizing the execution node completely isolates the tests from the underlying host server environment. A Docker file defines the exact browser versions and operating system requirements. This guarantees an identical, clean execution state for every single run, eliminating localized hardware discrepancies. Docker ensures consistency, but sequential execution remains far too slow for real-time CI/CD feedback. To scale our speed, we deploy Selenium Grid. The Grid Hub receives the execution request and instantly distributes the workload concurrently across multiple parallel browser nodes. The routing mechanics are highly structured. Jenkins issues the command to Maven, and Maven sends the execution requests through the Grid Hub, allowing dozens of browser tests to run simultaneously. A regression suite that previously bottlenecked the pipeline for hours sequentially can now be completed in a fraction of the time. Docker guarantees accuracy through environmental consistency, while Grid guarantees viability through speed. Together, they remove the final barriers to enterprise scale. Look at this complete 7-step enterprise architecture: code commit, webhook trigger, code pull, Maven build, containerized execution, and finally, reporting and notification. Post-execution, the pipeline translates raw terminal data into clear visual documentation using extent reports. The final automated action of the pipeline is distribution. The system instantly pushes pass or fail notifications directly to stakeholders via email or Slack, with comprehensive reports attached. This setup enforces the core best practices of modern validation: trigger testing on every commit, isolate the environment via containers, parallelize the workload via Grid, and schedule thorough nightly regressions. The accomplishment here is systemic. This entire highly complex sequence operates with absolutely zero human input after the developer types git push. A test script provides little value if it remains trapped on a developer's machine. By integrating it into a CI/CD pipeline, we transform a local script into an automated asset that secures the entire delivery process.